All right, so today we're going to be talking about an idea called completing the square. And completing the square can do some handy things for us. The primary thing that we care about is, I guess the two things we care about is it'll help us solve icky looking quadratics. But the thing that I usually use it for is converting a quadratic that's kind of missing pieces, or it's in a weird form, into vertex form, because vertex form is way easier to manipulate and way easier to move the graph around like in your mind. So the entire idea behind completing the square is this right here, b divided by 2 over a. And if you can get that part, like that's almost the entire lesson. The only confusing part is because it's equations, what we do to one side, we have to do to the other, and that can be a little bit weird sometimes. So in my notes, when I do this, because this is how my teacher taught me, I always write b over 2 squared off to the side when I'm doing these, just to keep myself organized so that I know what I'm doing. So anyway, what we're going to do is take a look at this one right here first. So if I have the equation x squared minus 14x, I can use completing the square to write this out as a perfect square trinomial and then factor it. So what I'm going to do is I'm going to identify my b is negative 14. That's my step 1. My step 2 is b over 2. So negative 14 divided by 2, negative 7. And then my third step is to take this answer and square it. So negative 7 squared is positive 49. That means that what this really ends up saying is x squared minus 14x plus 49. Then I can use my rule for perfect square trinomial and factor it, and I get x minus 7 squared. Done. So my answer for this, if I solved it for 0, would just be 7. That's a lot faster than using quadratic formula if I have the option to not do it. Well, let's look at the one over on the right here, x squared plus 9x. Even if it's a weird number, it still works. So my b is 9, step 1. Step 2, I'm going to divide it in half, and that makes 9 over 2. I can't do anything. I can't reduce that fraction, so it just is what it is. Then 9 over 2 squared is 81 over 4. All right, cool. X squared plus 9x plus 81 over 4. I'm going to go back and do my perfect trinomial rule, and it gives me x plus 9 over 2, the quantity squared. A personal trick of mine when I'm looking at factoring this down to a perfect square trinomial, if you can do that, is usually this value, the b, and is what goes here in your factors. And if you hadn't noticed that. But we're not always factoring, so I'm just going to make that kind of an aside. And it pretty consistently works, like this example here, x squared plus 3x. My b is 3, so b over 2 is 3 over 2. Square that, get 9/4. If I factor it into a binomial, it's x plus 3 over 2, quantity squared. So if we're factoring, that's my trick. I'm sure it's not the official trick, it's not in the book or anything. So we'll do one more like that. So z squared minus 10z. My b is, uh-oh, I messed that up. That should have been a negative 10. Negative 10. And negative 10 over 2 would be negative 5. And then negative 5 squared would be positive 25. So let's see, this should have been a plus 5. No, that's a minus 5. I mucked something up in there. That should have been a negative 10. And then we can factor it and get z minus 5 squared. I'm trying to figure out what this over here is for. I'm losing my mind. All right, so that's how we take one of these and complete the square so we can factor it into a binomial. There is more for us to do, though. And this is the part that is a little bit more of a bummer. I apologize, my work is kind of messy. So we're going to do the exact same thing as before, okay? Except before we do that, we're going to move the x's to one side and the constants to the other. So step one is write the polynomial in standard form. Then we're going to factor the GCF. Then we're going to complete the square. And then we're going to solve it. So for this example here, do I have like a laser pointer or something I can... I'm not used to using this for this. Oh well. So my first step is to get this negative 6x with the x squared. I want all the x stuff together on one side of my equation. So I added 6x, and I get x squared plus 6x equals 27. Now I'm going to do completing the square. So my b is 6, b over 2 is 3, 3 squared is 9. I'm going to put that on both sides of my equal sign. That's the only weird part about this, is it goes on both sides of the equal sign. So on this side, x squared plus 6x plus 9, that's a perfect square trinomial, and it gives me x plus 3 squared. Done. The other side, I am going to add 27 plus 9, I get 36. Now I can solve it, okay? So when I solve a square like this, I'm going to break it up into two pieces. I've got my x plus 3 equals the positive root of 36, and then I've got x plus 3 equals the negative root of 36. So I'm taking the square root of both of these. In a square root, you always get two roots, a positive and a negative. So that means I'm just going to take square root of 36, get 3, square root of 30, or the square root of 36 is 6, 6 minus 3 is 3. Square root of 36 is, this one's going to be negative 6. Negative 6 minus 3 gives me negative 9. These are my two solutions. So in this part, the only kind of new thing, you know, to my mind, is we add it to both sides, and then when we take the square root of both sides, you get the positive root and the negative root. So let's take a look at this one here. I've got 2x squared plus 8x equals 12. I've already got all my x stuff on one side, so I don't have to move anything, right? But I don't want to have this 2, because I see I can divide 2, 8, and 12 by 2. So I just divide everything. And I get x squared plus 4x equals 6. Now I'm going to do completing the square. 4 divided by 2 is 2. And then 2 times 2 is, or 2 squared is 4 again. So I get x squared plus 4x plus 4. And then on the other side, 6. And I'm adding the same 4 to the other side. I factor this perfect square trinomial to x plus 2. I add 6 and 4, and I get 10. I'm going to take the square root of both sides. So I get x plus 2 equals positive root of 10. X plus 2 equals negative root of 10. Now this one's a little bit weird because the root of 10 does not have like a perfect number. I'm not going to get a calculator out. That's ridiculous. I'm just going to leave it as root of 10, a negative root of 10, and subtract the 2 and I'm done. This is totally acceptable to do. Don't bother getting a calculator out. We're not being that extra with this. The other kind of situation we can get into is when we get answers like we talked about with the imaginary numbers, the complex solutions. So on this example here, now I've got my x squared and my x together, but I want to get this 145 to the other side, so I subtract it as my setup step. Now I'm going to take my b value, I'm going to complete the square. So 24 divided by 2 is 12. 12 squared, I'm going to add 144 to both sides. I'm going to factor this. Now I get x plus 12, the quantity squared. Then the negative 145 plus 144 gives me a negative 1. So when I take the square root, I end up with square root of negative 1 on both sides. I end up with i's, right? So I have x plus 12 equals I, and x plus 12 equals negative I. So I subtract the 12s, And this is one of the style things. It's a plus bi, remember? So I did negative 12 plus I and negative 12 minus I. And that's also a totally acceptable solution. So again, the steps with these, when I learned this, I had trouble with it until I figured out what the steps were because my teacher didn't exactly explain them. Get all your x stuff on one side and your constant on the other. Once you've done that, if you can factor out a GCF, do. I'm gonna say most of the time you can't, but once in a while, like on that middle example, once in a while you can. Once you've done that, complete the square, b over 2, then square your solution, add it to both sides, then factor and solve. So I think this is, honestly, to me, this is probably the most complicated thing we've done all year, like straight up. This last one was everything, plus it was an annoying fraction. So I'm going to go through that one too. No fun unless I go through the annoying ones. Let me zoom in. All right, so this one. My first step, I got all the x's to one side and my constant to the other. I subtracted a 7 right here. My second step, I saw that there was a GCF I could factor out. I could divide everything by 3. So I did. Right here, and I ended up with x squared minus 6x equals negative 7/3. The negative 7/3 kind of sucks, but I'm going to deal with it. I'm going to do my completing the square, okay? So negative 6 divided by 2 is going to be negative 3, and negative 3 squared is 9. So I'm going to add 9 to both sides. Done. I am going to go ahead and factor my trinomial, so I get x minus 3, the quantity squared. On the fractions, what I did in my head, I didn't write it down. I just said that 9/3 is the same as, or that 9 is the same as 27 divided by 3. And 27 minus 7 is 20. So that's where that came from. Then I went ahead and solved it. So I get x minus 3 equals the positive root of 20 over 3 and the negative root of 20 over 3. I added my 3 and I added my 3 to both sides. And this one, I shifted the negative. I multiplied by negative 1. And then I simplified my my root. That should be, yeah. The square root of 20, for what it's worth, is 2 roots of 5. And there is a better answer than this, okay, with rationalizing our denominator, but I'm not going to make you deal with that because I'm not that kind of guy. I talked to your calculus and pre-cal teachers, and they said that they're not going to do that, so I figured, why make you go through all the hassle? If you want to rationalize it, I was in the simplifying radicals, I did see some people that did do it. That's awesome. That's above and beyond. Your college professors will be thrilled with you. If you can do it, I would encourage you to do it, but I'm not going to beat you over the head if it's not like that, okay? You got enough stuff to worry about. Whew. Did I do all these ones? I think I did. Because say if there was one I could pull out and do another example. So in the work, if you have a question, you feel like you didn't get it, please let me know. Like, I will open this up and I will do another example for you. I know that for me personally, this was one of the more confusing things that I learned when I was in Algebra 2. My classmates didn't all agree, but I struggled with it personally. So I'm here to help if if you're like, I don't know where to start, I'm stuck, I don't understand what to do at the end, any of that, I'm here for you.